Okay guys, in this video we're going to be looking at probabilities. Probabilities are involved in all sorts of places in life, whether it's figuring out how to win at your favourite gambling game, or whether it's figuring out the Schrodinger's equation in quantum mechanics. Probabilities are ubiquitous throughout the natural world. They crop up in some places you wouldn't expect them as well. But for this video we're just going to be looking at the basics. And probabilities are simply a decimal or a fraction or a percentage. They're all the same thing, really. In this case, we're giving it as decimals. 0.5, for example, could be written as a half, or it could be written as 50%. Fractions, decimals, or percentages. So, we have a range from 0 to 1. A probability cannot be larger than 1. It can't be less than 0. A probability of 0 means something is impossible, a probability of 1 means that it's absolutely certain, and a probability of 0.5 means that there's an even chance. It's halfway between. If you, for example, flip a heads and tails coin, there's an even chance in theory that it ends up as heads or tails. So that would be a 0.5 chance of a head. And lower down on the scale, very unlikely, higher up, very likely. Now, probability is essentially measured as the number of ways that you come up with something divided by the total possible outcomes. So let's say we roll a dice, or roll a die rather, and we come up with the number 3. What was the probability that we came up with the number 3? Well, what are the number of ways in which we can make 3? Only one. There's only one side with a 3, so it's that 1, 3, divided by the total possible outcomes, of which there are 6 sides to the dice. There were 6 possible ways that it could have gone. And so it's 1 over 6, or 1 divided by 6, or 0.16 recurring. So the probability of rolling a 3 is 1. There's only one 3 available divided by the total possible outcome 6. Let's say we have a list of names instead. Let's take John, Ella, Dave, and John again. What is the probability? And probabilities are often written as P with brackets like this. What is the probability of, in this list, we're going to choose something at random. What's the probability we land on John? Well, how many ways can we land on John? There's one way, and that's the first John, and then there's a second way, that's the fourth John. So there are 2 ways to land on John, divided by the total number of possible outcomes. That's 1, 2, 3, 4 in the list. So we have the probability is a half, or 0.5. There's an even chance that we'll end up on John or not John. Finally, let's do one last one. What's the probability of not Ella? What's the probability that I do not land on Ella? Well, how many ways are there that I do not land on Ella? There are 1, 2, 3 ways. There are 1, 2, 3 ways that I don't land on Ella, and there are 4 possible outcomes. So you've got 3 over 4, or 0.75%, 0.75 rather, chance, 75% chance of not landing on Ella. Now, experimental probability, also called relative frequency, is different from the case of a dice. If you have a fair dice and you roll a 3, you've got a 1 in 6 chance. That's a theoretical probability. An experimental probability is done with testing, with experiments. So, Ben throws a die 10 times and he rolls 4 3s. What's the relative frequency, or the experimental probability, that Ben rolls a 3? We don't have to consider the theoretical case. All we do is we look at what was done in this experiment. So we had 4 3s divided by the 10 rolls. So it was 4 3s out of 10 rolls. And so we get 0.4 for our probability that Ben rolls a 3 in this experimental probability. What do you think will happen if the die is fair and Ben rolls 100 times rather than 10 times? We already saw that the chance in a fair die is 1 in 6, or 0.16 recurring, which is less than this. So what do you think is going to happen to Ben's experiment if he rolls the die 100 times? Well, that 0.4 is going to go down and down and down, and it's going to start approaching the true theoretical probability, assuming it's a fair die. How many ways are there to order the letters A, B, and C? This is a common question in your exams. It's just basically listing these different ways in which it can occur. The trick is to come up with some systematic approach. So here we're going to do it in alphabetical order wherever possible. So we're going to start with listing the obvious one, A, B, C. And there's another A. We're going to do it in alphabetical order where possible. So we'll start with A. We can't do BC. We've already done that. But we can do CB. Can we start another one with A? No, because we've already got those. So now we'll go in alphabetical order where possible. B. And again, alphabetical order where possible. We'll start with A, then C. We can still start with a B, but now it's got to be a C, and then followed by an A. And we've done all our A's, we've done all our B's. So now, starting with a C, again, alphabetical order where possible. A comes first, followed by B. Now a C, and we can't do A, so it's B, A. C, B, A. So, how many ways are there to order the letters? There are 6 ways to order A, B, and C. Now, sample spaces are very useful, and you'll see why right now. Here's a spinner, and it's a fair spinner with 1, 2, and 3, an equal probability of landing on 1, 2, or 3. I'm going to spin this spinner twice, and I'm going to add up those 2 results. So if I span a 2 and a 3, I'd add them up to get a 5. What is the most likely outcome? Now, you might be thinking, well, what difference does it make? If it's a fair spinner, I'm just as likely to get a 1 plus 3, which is 4, than I am to get a 2 plus 3, which is 5. So it doesn't matter. All my outcomes are equally likely, right? I'm afraid that's not true. You'll see why right now. I'm going to draw out, let's change the color of that. You'll see why right now. I'm going to draw a sample space table here. And what we're going to do here is we're going to list the different results that we could get on the spinner, vertically and horizontally. And we're going to assume that we get these and then add them up. So this is at the top, throw 1, and this is along the left, throw 2. So throw 1, I get a 1, throw 2, I get a 1, I add them up, 1 plus 1 is 2. Throw 1, I get a 1 again, throw 2, I get a 2, I add them up and get 3, and so on. So I add up all the possibilities to here. 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5. Throw 1 is a 3, throw 2 is a 1, throw 1 is a 3, throw 2 is a 2, and throw 1 is a 3, and throw 2 is a 3. These are all the possibilities. What is the most likely outcome? Well, notice here are all our 9 possible outcomes. There are 3 ways that I can get a 4. I can get a 3 followed by a 1, I can get a 2 followed by a 2, or a 1 followed by a 3. There is only one way I can get a 2, that's a 1 and a 1, and only one way I can get a 6, which is a 3 and a 3. So as you can see, a sample space shows us very clearly that the outcomes are not equally likely. So the answer is, the most likely outcome is 4. Time for an exam question. There are 26 sweets in a bag, 15 of them are red, the rest are white. One of the sweets is taken at random. Find the probability that the sweet is red. Okay, nice and straightforward this one. 26 sweets in the bag in total, so we know it's going to be out of 26. We just need to know how many reds there are. There are 15 reds. Are any of the other sweets going to be red? No, tells us very clearly the rest are white. So we've got 15 chances to get a red out of a total of 26 chances. So the final answer is 15 over 26. Now you can turn this into a decimal, or if it's an unsimplified fraction, you can simplify it, but that is a good enough answer for an exam question, just putting the final probability in the answer. as a fraction or a decimal. Okay. Okay, time for one for you all. Let's see how you get on with this. We are dealing with a biased spinner, and see if you can first complete the table and then work out the estimate for the number of times the spinner will land on 2, given that Johnny spins it 200 times. I'd like to see your answers in the comments section. If you would like to see if you're right, let me know. My name is Adam, a tutor for Sherpa. Any other tutor for Sherpa can also give you the answer to this. But please do have fun trying to get this one. I'll see you in the comments section. Goodbye.